This video is on product and quotient rules. These are two early rules that you learn in order to calculate the derivatives of functions that are a little bit more complex than your most basic ones. The idea behind product rule is if you have one function times another function, the derivative will be the derivative of the first times the second plus the first times the derivative of the second. As an example, let's say I have y equals x cubed times x squared plus 4. Now, there are two ways I can calculate this derivative. I'm going to first calculate it using product rule, and then I'm going to calculate it by multiplying it out and then using the power rule to show that the product rule works. So using product rule, I take the derivative of the first, so that involves product rule, times the second, plus the first times the derivative of the second. X squared becomes 2x, 4 becomes 0. And I'm going to go ahead and multiply this all out so I will be able to compare it later. Okay, so I found this derivative using product rule. Let's confirm that product rule works, at least in this specific example, by instead multiplying it out first and then calculating the derivative. So these do match. Now in this specific example, it was easier to multiply out and take the derivative rather than apply product rule. However, as these functions get more complicated, increasingly that won't be an option, especially if these are not just polynomials, but this is a trig function and a polynomial. You will basically need to use product rule. Quotient rule covers fractions. So if your function is a rational function, or just any quotient, the derivative of this will be derivative of the first times the top times the bottom minus top times the derivative of the bottom all over the bottom squared. I think some classes learn this as low d high minus high d low over low squared. I honestly don't know if that's easier to memorize or not. The only difference between this and this is that I guess they reverse the order here, but it's multiplication, so it doesn't matter. If you prefer to memorize it this way, go ahead. If you want to just sort of memorize it as related to product rule, except with the minus sign here and divided by the bottom squared, you can do it that way. So if I have y equals 5x cubed plus 1 over 2x, again, I'm choosing one that I can simplify and take the derivative first, or use quotient rule. I'm doing quotient rule even though it takes longer just to illustrate that it works. So applying quotient rule here, I'm taking the derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. Okay, and I'm going to compare that with what would happen if I instead divided out that 2x with, divide each term on the top by that 2x first to simplify. I'm rewriting 1 over 2x as 1/2 x is negative 1 to more easily illustrate power rule. And I take the derivative of that. Rewriting this without a negative exponent. And then maybe to compare it a little bit better, I'm going to go ahead and divide out this piece to show that these are the same. Oh, something's wrong. No, sorry, I dropped an x squared here. Okay, so I divide that out. And yes, these are the same. Again, with this specific example, it may have been easier or shorter to divide it out first. However, if I have a sum or a difference here in the bottom, it's probably not worth it to actually do long division and then use just power rule. You may want to just use quotient rule. I will say also with quotient rule involving polynomials, although you might be tempted to leave the answer in this form, generally speaking, you may have some cancellation or consolidation here, and so it's probably a good idea to simplify out the numerator. The denominator you do not necessarily have to multiply out. It depends on what your teacher requires, how simplified your final answer needs to be. So for instance here I could have simplified it a bit by dividing out a factor of 2 in the top and the bottom. Okay, hope that helps.